Hello learners, welcome to CM course on CAD CAM. I am Dr. K. Tamilmanan, Associate Professor, Mechanical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. Today we are going to discuss the topic on Computer Aided Design Solid Modeling. Solid modeling is an important component in the geometric modeling. It is one of the type of geometric modeling. So it is an important component in the CAD software system. What is solid modeling? What is the need of solid modeling? Why should we study about solid modeling? Solid modeling is basically a consistent set of principles for mathematical and graphical representation of three-dimensional solids. Basically, it's a mathematical techniques which is used to represent the solid objects. It is the best method for three-dimensional model construction is the solid modeling techniques. The solid modeling technique is one of the best method for three-dimensional representation of the image or objects. It provides the user with complete information about the model. This is the main advantage of this solid modeling, the main benefits of solid modeling. The solid modeling provides complete information about the model, image or object. When the color is ordered in the image, the resulting picture or image becomes very realistic. When we can add the color in the image or object, it shows the reality of the image. All solid modeling systems provide facilities for creating the images, new images, objects, and modifying the existing images and inspecting the models of three-dimensional solid objects. So apart from that, this representing the solid modeling, it also provides the facilities for creating the new object or images, also modifying the existing objects or images and inspecting the models of three-dimensional solid objects. In this approach, the models are displayed as solid objects so that the viewer with very little risk of misunderstanding. So that this approach can be used that represent the all images or object in the form of solid, so that less misunderstanding will take place, less error will introduce in the object. There are variety of solid modeling primitives are utilized in the solid model, such as block, cylinder, cone, hexagon, sphere, quadrilateral, torus, tube, wedge. These images are shown in the figure. Constructive solid geometry using Boolean operators. The Boolean operators are used for combining the primitives to the form of complete and solid object. There are variety of these Boolean operators are available for the construct the solid geometry. It's for that union to adding the elements or components or objects, intersecting the two components and differentiating the two components or deleting the two components, deleting the components from the main object. These are the Boolean operators which is used for construct the solid geometry. The image shows that object group A and group A2, similarly for group B1 and B2. The group of faces are collected according to the specific Boolean operation and unnecessary face groups are eliminated, so that the union operation group A1 and B1 are collected and A2, B1 are eliminated. Similarly, that the Boolean operations in object A and B, we have that if adding the object A and B, we can have this object like this. Similarly, if we deleting the objects, we can have object like this, and if you're differentiating object, you can have like this. There are various solid modeling techniques are used in to creating the solid modeling, such as constructive solid geometry, boundary representation, hybrid scheme. These are the three techniques which are used for constructing the solid modeling. Among the schemes, constructive solid geometry and boundary representation techniques are widely used in CAD systems. The hybrid scheme is not much using in the solid modeling for creating the solid modeling in CAD systems. Constructive solid geometry. It's also called CSG or C representation. This approach is also called building block approach. The constructive solid geometry is also called building block approach because it's constructed the block by block of the solid modeling and solid geometry. In the constructive solid geometry approach, a solid object is represented in a system as a combination of simple solid objects called primitives. So that various primitives is combined together have the solid object or solid model. This is the most common method of structuring the solid model in graphics database using the Boolean operations. So the Boolean operations is performing to construct the various solid model. So that some typical primitives are utilized in the solid models are block, sphere, hemisphere, cylinder, cone, torus and wedge. The primitives are normally stored internally using the analytical representation. This figure shows a constructive solid geometry. This object A and object B, which is joining these two objects and object A and object B, we can have the new object. This combining these two objects, we can have the new objects by using the Boolean operations. In constructive solid geometry, the storage of data required for the complex job is only construction of tree of the operators and relevant dimension of the primitives. It's required to construct the solid geometry for the complex job. So operator need that construction of tree and relevant dimension of the various primitives. Also by making the modification in constructive solid geometry tree, the new object can be obtained anytime by using the Boolean operators. The facilities the reduction of the storage requirement. The facilities which provide the reduction of the storage requirement. The Boolean operators always generate the objects formed by those rules are physically realizable. This image shows constructing the solid geometry by using the Boolean operations. This is the object which has been making the difference between the P1 and P2. We can have the two different objects. Similarly, addition, we can add the objects, these two objects, we can have the new objects. Another technique is called the boundary representation. It's also called B-rep. Boundary representation approach requires the user to draw the outline or boundary of the object on the CRT screen. So mainly the boundary representation is represent the outline or boundary line of the objects in the CRT screen. By using electron pen or tablet or analog procedure also used to represent the boundary representations to create the solid model images. In the boundary representation scheme, a solid model is represented by the data structures containing the elements which describe its boundary. All elements in this boundary representation is describe the various boundary of the solid model. This boundary, this object as shows that the top, face, bottom, side. So these are various boundary has been represented by using the boundary representation. The solid model objects boundary has been represented through the boundary representation techniques. The boundary representation such as geometric entities such as point, curve, surface, and topological entities such as vertex, edge, face, edge loop, and elementary surface, plane, cylindrical, and so on. These elements divide into topological elements as well as geometrical elements. The topological elements are linked together in a network or group. The topological elements such as vertex, edge, and face that has been linked together in the network or group, which represent the interconnections or connectivity of the terms of vertices, edges, and face. It interconnect the vertices, faces, edges, body, so that we'll have the complete solid model by using the boundary representation. The geometric elements are points, curves, and surfaces. The geometric elements are also represented by points, curves, and surfaces. The various transformation and other specialized editing procedures are used to refine the model to the desired shape. So that according to our desired shape, the various transformation and other specialized editing procedure are also used to refine or construct the model in boundary by using the boundary representation techniques to get the desired shape or desired objects. Now we are comparing the constructive solid geometry and boundary representation. How we can compare the constructive solid geometry and boundary representation? In constructive solid geometry, the solid model is built from solid graphic primitives. In boundary representation, the solid model is obtained creating the outline or boundary of the object. So, in constructive solid geometry, the solid model constructs from the various graphic primitives such as cone, sphere, cylinder, and so on. But in boundary representation, solid model is obtained by creating the outline or boundary of the object. It is in constructive solid geometry, it is easy to construct a precise solid model. So that by using constructive solid geometry, we can have the precise solid model. But it's not possible by using boundary representation to construct such model. It uses Boolean operations. Constructive solid geometry using the various types of Boolean operation such as adding, deleting, and intersecting. But in boundary representation, it uses the topological elements instead of Boolean operations. It requires less storage space in constructive solid geometry. In boundary representation, it requires more storage space. So that constructive solid geometry, it makes a complete model, so that it requires the less storage space. But in boundary representation, it's represented through the boundary of the object or outline of the object, so that it requires the more storage space. In constructive solid geometry, it requires more computational to reproduce the model. So due to that it's complete solid geometry, it requires more computational to reproduce the model. But in boundary representation, it requires less computation to reproduce the model. Due to that, it's representing only the outline or boundary of the object. Non-analytical surface such as Bezier surfaces cannot be created. So that non-analytical surface, the Bezier surfaces cannot be created by using constructive solid geometry. But in boundary representation, non-analytical and complicated surface can be created because that it's showing only the outline and boundary of the object. Conversion between the C-rep and corresponding wireframe model is very difficult because it creates a complete solid model. But in boundary representation, the conversion between boundary representation and corresponding wireframe model is possible. Make it very easy because wireframe modeling and construct and B representation also having the same techniques, the same kind of techniques using in the creating the construct the models. so that the wireframe model can be easily we can construct by using the BREP techniques. Third one is the hybrid scheme. It is a combination of both constructive solid geometry and boundary representation approach. So it's combining the both solid geometry as well as boundary representation approach. We can have the hybrid schemes. It makes use of relative benefits of both approaches, overcoming the relative weakness. So it have the hybrid schemes has both benefits also there, also the same time have the weakness also there when compared to the each methods. By using this approach, solid models can be created by either CREP or BREP, whichever is more appropriate to the particular problem. So that in this hybrid scheme approach, either we can use constructive solid geometry approach or boundary representation approach, whichever is more suitable for the particular problem, which at specified problems. What are the application of solid modeling? There are various applications of solid modeling, such as creating hidden line drawings, sections, and shaded images. So this is are possible in solid modeling. Also can calculate the mass properties such as total surface area, volume, center of gravity, moment of inertia, radius of gyration, and so on. Also, the solid modeling, the self-adaptive finite element measures and generation is possible in solid modeling. Also, we can have the various types of finite element analysis, such as stress strain analysis, structural analysis, beam analysis, vibration analysis, and kinematic analysis of solid assemblies. So various types of kinematic and dynamic analysis is possible in solid modeling. Also the various types of finite element analysis is also possible by using the finite element method. The finite element method is a method of predicting behavior of real structures under various load and displacement conditions. So that dynamics interference analysis also possible in solid modeling, and process planning for manufacture also is used. CNC program generation and toolpath simulation and program verification also the solid modeling used for the manufacturing of the products and components. Some advantages of solid modeling, such as solid model is complete and more understandable, so that designer can quickly to understand and create the solid model of the image. Solid models can be created easily because it's easy to understand. There is no ambiguity in the solid modeling. It gives information about interior details. So the entire interior details of the object or images, it gives the complete information. There is a little human intervention for automated application, like creating part programming. So creating the part programming, the human intervention needed for the automated application. Otherwise, it's create the everything in automatically create the image constructive the solid geometry. It stores more information about geometry and topology of the object. So in that solid modeling, we can have that store the details and mathematical description of geometry and topology of the object. It is best suitable for mass property calculation. So various type of mass property we can calculate for the solid modeling construction. Some few disadvantages also of solid modeling, because that it needs a complete entire geometrical data, so it needs more space for occupying the memory. It requires the more space for to store the various mathematical description and components of the solid model. It requires more manipulation time due to the complete information of the solid modeling. So now we can compare the wireframe, surface, and solid modeling. In the objects in representation, in the point of representation, in wireframe model, collection of corner points and edge lines only. In surface model, collection of corner points, edge lines and surfaces. It includes surfaces also. In solid model, collection of corner points, edge lines, surfaces, internal volume, everything which includes in solid modeling. In ambiguity, there is more ambiguity in wireframe model, less ambiguity in surface model. There is no ambiguity in solid model. Memory requirement is in wireframe model, it requires very less memory space, and surface model requires more than wireframe model, and solid model requires more than surface model. Manipulation time is wireframe model is less, surface model is more, and solid model is less. Interior detail, so interior details of the object or images, it's not possible to view in wireframe model, but not possible in surface model, but possible in solid modeling. Automatic view generation, it's impossible in wireframe model, impossible in also in surface model, but possible in solid model. The cross sectioning facilities manually guided in wireframe model, also it's manually guided in surface model, but in solid model possible in automatically. Elimination of hidden lines, also that in wireframe model needed manually guided, and surface model also manually guided, but automation is possible in solid model. Mass property calculation is not possible in wireframe model, also not possible in surface model, but possible in solid model. And numerical control concern that it's difficult in wireframe model and automatically possible in surface model, but it's completely possible in surface solid modeling. There are various software which are used for designing of solid modeling. For two-dimensional, we can have AutoCAD and TurboCAD. For three-dimensional solid modeling, we can have Pro-E, Wildfire, and SolidWorks. In this software, we can use the create and construct the solid model image or object. For analysis of the solid modeling, we can have the ANSYS fluids and CATIA. So far, we have discussed various topics in solid modeling, various techniques of solid modeling, various classification of solid modeling, application of solid modeling, advantages and disadvantages of solid modeling. Also, we have discussed the creation of solid modeling by using Boolean operation techniques such as constructive solid geometry, CSG or CREP. Also, we used boundary representation technique, BREP. Comparison of solid geometry and boundary representation. Also, we have discussed comparison of wireframe modeling, surface modeling, solid modeling. Learners, hope you might have understand the various concepts and functions of solid modeling. Hope we have covered all the topics, all the lectures in computer aided design. Thanks for patient listening.